Have you ever stopped and wondered, where did it all begin? Where did the universe, with its vast galaxies, stars, and planets, originate from? In the grand tapestry of existence, our universe, with its countless stars, galaxies, and celestial bodies, is but a single thread, a thread that began weaving itself nearly 14 billion years ago. But where, how, and why did it all start? To answer these questions, we must journey back to the very dawn of time itself. This journey takes us to the Big Bang, a concept that has intrigued and baffled the greatest minds of our generation. Imagine, if you will, an infinitesimally small point, a singularity, where all the matter, energy, space, and even time were condensed. This singularity, smaller than the tip of a needle, held within it the seeds of the universe as we know it. Then, in an instant, a moment less than a fraction of a second, this singularity began to expand. It wasn't an explosion as the name Big Bang might suggest, but an expansion. An expansion so rapid and so intense it gave birth to everything we see, everything we know, and everything we are. From this tumultuous beginning, the universe unfurled like a cosmic flower in bloom. Stars ignited, galaxies formed, planets coalesced, and life as we know it took root. All from a single point, a single moment, a single bang. The Big Bang isn't just a theory. It is the most widely accepted explanation for the origins of our universe. It's a story that combines physics, cosmology, and a bit of mystery into a narrative that has captivated the imagination of scientists and laypeople alike. So, as we delve deeper into this tale of cosmic inception, remember, every star you see, every planet you know, every atom in your body traces its history back to that singular moment. A moment when everything, absolutely everything, came into being. The Big Bang isn't just a theory, it's the most widely accepted explanation for our universe's origins. But what exactly is the Big Bang? Is it an explosion or something else? Well, let's dive into the origin of all things, into the very first moments of our universe's existence. The term Big Bang may evoke images of a massive detonation, a colossal explosion of matter into the void of space. But that's a bit of a misinterpretation. The Big Bang is less about an explosion and more about an expansion. Imagine, if you will, a state of infinite density, a point of unimaginable heat. This is what cosmologists refer to as a singularity. All the matter, all the energy, everything that would eventually form the galaxies, stars, planets, and even you and me was compressed into this singularity, a point smaller than the dot at the end of this sentence. Then, in less than a blink of an eye, this singularity began to expand. This wasn't an explosion in the traditional sense, with debris flying out into pre-existing space. No, this was the birth of space and time themselves. This expansion is what we call the Big Bang. As this singularity expanded, it cooled. Energy transformed into particles. Particles combined to form atoms, and these atoms eventually came together to create the stars and galaxies we see today. So, in essence, the universe as we know it was born from this rapid expansion and cooling. This concept might seem a bit abstract, and honestly, it is. But that's the beauty of our universe. It's full of mysteries waiting to be unraveled, full of stories waiting to be told. So let's correct our earlier misconceptions. The Big Bang isn't a fiery explosion that happened somewhere in space. Instead, it was the rapid expansion of space from a state of infinite density. It's not an event that happened at a particular spot in the universe, but an event that happened everywhere, because it was the birth of everywhere. So the Big Bang isn't an explosion in space, but an expansion of space itself. How can we be so sure that the Big Bang happened? This question brings us to the third part of our exploration, the evidence. The Big Bang theory isn't just a random idea thrown into the cosmos. It's supported by tangible, observable phenomena that we've detected right here from our home planet. Let's start with the cosmic microwave background radiation, or as scientists like to call it, the CMB. This radiation is like the afterglow of the Big Bang, a snapshot of the universe when it was just a mere 380,000 years old. The discovery of the CMB in the mid-20th century was a monumental moment for cosmology. It provided the first significant piece of evidence that the universe originated from a hot, dense state, just as the Big Bang theory predicted. The CMB is remarkably uniform across the sky, but it has tiny temperature fluctuations. These fluctuations are like the seeds from which galaxies and clusters of galaxies grew. They give us a glimpse of the universe's primordial structure, further supporting the idea that the Big Bang set the stage for the cosmic drama we're part of today. Now, let's turn our gaze from the radiation that fills the universe to the galaxies that populate it. When we look at distant galaxies, we notice something peculiar. They appear redder than we'd expect. This phenomenon, known as redshift, happens because these galaxies are moving away from us. The further they are, the faster they're moving, stretching the light they emit towards longer, redder wavelengths. This redshift of galaxies is another piece of compelling evidence for the Big Bang theory. It suggests that the universe is expanding, and if we trace this expansion back in time, we reach a point when everything must have been crammed together in a single, infinitely dense point, the singularity from which the Big Bang erupted. These pieces of evidence make the Big Bang theory the best explanation we have for the origin of the universe. They don't just tell us the universe began with a Big Bang, they paint a picture of a dynamic, evolving cosmos that's still resounding from the echoes of its fiery birth. What happened after the Big Bang? Well, in the immediate aftermath of the Big Bang, the universe was unimaginably hot and dense, filled with a sea of particles and energy. For the first few fractions of a second, it was so hot that particles of matter and antimatter were continuously created and annihilated in a flash. But as the universe expanded, it cooled. After a few minutes, it had cooled enough for protons and neutrons to come together and form the first atomic nuclei in a process known as nucleosynthesis. For the next several 100,000 years, the universe continued to cool and expand until it was cool enough for electrons to combine with these nuclei to form the first atoms. Now, with atoms in the mix, light could finally travel freely through the universe. This light, known as the cosmic microwave background, is still visible today, and it's one of the key pieces of evidence we have for the Big Bang. But the universe wasn't done yet. Gravity began to pull matter together into clumps, forming the first stars and galaxies. These stars lived and died, creating heavier elements in their cores, which were then spewed out into space when the stars exploded in spectacular supernovae. These heavier elements eventually formed new stars, and around some of these stars, planets began to form. On at least one of those planets, conditions were just right for life to emerge. And over billions of years, that life evolved into the diverse array of species we see today, including us, humans. In this way, everything we see around us, from the stars in the sky to the ground beneath our feet, is the result of processes that began in the immediate aftermath of the Big Bang. We are, in a very real sense, made of stardust. The universe as we see it today is the result of billions of years of cosmic evolution, starting from the Big Bang. Even with all we know about the Big Bang, there are still mysteries to solve. Indeed, our understanding of the universe's birth, while broad, is far from complete. There are questions that remain unanswered, mysteries that continue to baffle the best of minds. One such question pertains to the cause of the Big Bang. What triggered this colossal explosion that led to the birth of our universe? Was it a random occurrence, a spontaneous event in the void of nothingness? Or was there a prior universe that collapsed into a singularity, thus sparking the Big Bang and giving birth to our own universe? These are questions that scientists are still grappling with, trying to piece together the cosmic puzzle. Another mystery is the concept of before. When we think of time, we naturally consider a before and an after. But can we apply this concept to the Big Bang, an event that essentially created time itself? If time began with the Big Bang, what does before even mean? Is it a valid concept, or are we trying to apply our terrestrial understanding of time to a cosmic event that defies such comprehension? Then there's the question of the universe's fate. If the Big Bang was the beginning, what will be the end? Will the universe continue to expand indefinitely, or will it eventually collapse back in on itself, perhaps triggering another Big Bang? Again, these are questions that we don't yet have clear answers to. Finally, there's the question of dark matter and dark energy. These invisible, mysterious forces make up about 95% of the universe, yet we know very little about them. How do they relate to the Big Bang and the formation of the universe? What role do they play in the universe's ongoing evolution? As we continue to explore the cosmos, we may one day find the answers to these questions, further deepening our understanding of the universe's beginnings. These unanswered questions, these cosmic mysteries, serve as a reminder of just how much there is still to discover about our universe and its origins. They drive us to continue probing the cosmos, seeking answers, and deepening our understanding of the universe and our place within it.